Hello students, welcome to Uncle. Good evening to all.
Good evening, sir.
Good evening, sir.
Good evening.
Good evening, sir. Good evening, sir.
Good evening, everyone.
Good evening.
Good evening. Now, yesterday, in the last, we discussed about the isothermal compressibility. So, one small problem based on that. Isothermal compressibility. So, they have dropped that negative sign. Okay. So, we have to use this definition for this particular problem. For n moles of an ideal gas will be. Is it 1 by P, n by P, minus 1 by P, or minus n by P? What will be the answer? No, Siddesh, it's not like that. Very good, Kapil. Divya, it's wrong. It's wrong, Rita. Abhay, it's wrong. Very good, Arun. Yashri, it's wrong. It's wrong, Divya. Very good, Ramjal. Rita and Ravi, it's wrong. It's wrong, Rishika. See, the definition is Kt equal to 1 by V, curly V by curly P. Now, for n moles, we have PV equal to nRT. So, V is equal to nRT by P. Na? nRT by P. So, it becomes minus nRT by P square. Na? And nRT by P is what? V. Na? So, can I write it as minus V by P? Please check. Because nRT by P is V. Na? So, again, I substituted nRT by P equal to V. So, it is minus V by P. So, V got cancelled. We are left with minus 1 by P. That is the answer. So, C option is the answer. Everyone, please check. Clear?
Yes, sir.
Next one. The equation of state of an ideal gas is PV is equal to RT. Is independent of the temperature. This is called alpha actually. This volume expansion coefficient, it is denoted by the symbol alpha. And equation is given to be PV equal to RT, so you can make use of that equation. So similar to this one, just as we have calculated the value of Kt, it was coming out to be minus 1 by P. Similarly, you have to see the relation between alpha and T. That's it. Okay. It's wrong, Ravi. Very good, Arun. Very good, Kapil. It's wrong, Tanushri. It's wrong, Sanju. It's wrong, Divya. Yeah, now it's correct. Yes, Tanya, good. It's wrong, Rita. How can this be independent of temperature? Just think before answering. Temperature is already variable in this term. It's wrong, Sanju. It's wrong, Jayashri. It's correct. Sorry. It's Abhay, Sanju, and Jayashri. It's correct. It is option B. Very good, Mamta. Now see how to solve it. Again, we can substitute for V. Now, V will be RT by P. R is constant. We have to treat pressure as constant also. So it is coming out to be 1 by VR by P. Okay. So 1 by V will be P by RT into R by P. So it is 1 by T. Na? So B option. why they have written diverges low temperature. When T approaches 0, alpha tends to infinity, na? Means diverges.
So option C and D are the different?
Obviously, they are different. Na? It is saying it varies like T, and it is saying it is independent of temperature.
So varies or vanishes?
One and the same thing, na, I think. If it is proportional to T only, then it will vanish like T, na? Because T is small, T approaches 0. Then alpha will be 0.
Okay.
So now, first of all, we have to get the relation between KT and density, and of course pressure also. Only then we can get the answer, na? That how it varies by changing the density and modifying the pressure. What was the formula for KT? This, na?
Yes, sir.
Now, we know that volume is mass over density. So dV will be mass is constant minus m by rho square d rho. So dV by V is minus d rho by rho. It means I can write it as d rho by rho 1 by dP. Can I write it like this? Because in place of dV by V, we can write minus d rho by rho. Na? Is it? Is it clear or not?
Yes, sir.
So this is the formula we are looking for. So this will be the pressure required, and KT is given. This is the percentage change in density. So it will be like 1 by, because it is fraction and given is percentage, so it will be 1 by 100. Na? Okay, so 10 raised to power 8 Pascal. This is the answer. Because percentage means d rho by rho into 100. Na? Okay. Let me give you the formula for bulk modulus, and then you can try. Inverse of the compressibility, that is called bulk modulus. This. Now you can try it. Yes, Divya, good. Very good, Ravi. Very good, Ramjal, Rita. Very good, Sanju. Harun. Very good, Mamta. Let us see how it should be done. So the main thing is, away from, very good, Kapil. So the main thing is we need to find curly P by curly V. Na? and this relation is given. So P is proportional to V power minus 5 by 3. So P is of the form K time, where K is constant. Minus 8 by 3. So therefore, five by 3 K V power minus 5 by 3. So proportional to V power minus 5 by 3. That's it. You can check. Clear?
Yes, sir.
I have already given the definition, Rita.
Sir, mathematically.
This is bulk modulus. Change in pressure over volumetric strain.
Okay, sir.
This is volumetric strain. This is change in pressure. This is called bulk modulus. Or you can say change in pressure over fractional change in volume. That you can also say. Okay?
Okay, sir.
Try to understand the question. Question is simple, but first try to understand the process. Let me make the diagram. Have you noted the question?
Yes, sir. Yes, sir.
Because then it will be easier for you to understand this one. So there is a container in which some gas is contained, and there is a piston. This sort of piston is there. Okay, and then this is frictionless, this is rigid wall. Okay, so it is closed, pressed lightly and released. Gas is a poor conductor of heat, so the process is adiabatic. It means the gas is not absorbing the heat, and the cylinder and piston, they are perfectly insulating. So okay, so it is adiabatic. Cross section area is A. So let us assume that the piston is pressed by a small amount, delta x. So because of this, when we press the piston, the gas will be compressed, and as a result, it will exert a pressure P on the piston, isn't it?
Yes, sir.
Clear? This thing clear, na?
Yes, sir.
So now the process is clearly adiabatic. Is this thing clear to you? Because gas is given to be poor conductor of heat, and the cylinder, read this line, cylinder and piston are perfectly insulating. It means no heat is going outside the system and no heat is entering the system. Okay. So adiabatic. So it means I can use this now, PV gamma equal to constant. So now when we press the piston, the pressure will increase and the volume will decrease. Na? Please check. This will be the new pressure and new volume. Na?
Yes, sir.
If I take pressure common and if I take V power gamma common, okay, this is the new one. This is the old one. Okay, but these two should be equal. Na? If PV gamma is constant, then the old product should be equal to new product. Isn't it? Please check. So now, can we make use of the binomial theorem? Of course, this PV gamma and PV gamma, it got cancelled from both the sides. So 1 equal to, this will remain as such, and here, retaining the first term. So using binomial theorem and neglecting higher terms. As delta V by V, it is very small. So the next term will be delta V by V square. So that will be further smaller. Okay, so 1 equal to, now we can multiply these. And now again, we will be getting one more term containing delta P by P. Let me write that term. So this is the product of two small quantities. Okay. So this one to be neglected. Okay.
Yes, sir.
Being product of
Small.
small terms. So this 1 and 1 again it will get cancelled, and we can bring this gamma term onto the left hand side. So this is the relation. So can I write it as A delta P by AP by multiplying and dividing by A, where A is cross sectional area? It is given, I think, in the question. I think it was given. Yes. See, cross sectional area of the cylinder. Clear? Now, the force exerted by the gas on the piston. So same will be the cross sectional area of the piston, because the piston is exactly of the same size as that of the cylinder. And P is the pressure. So force exerted on the piston by the gas will be P into area, because force is pressure into area. Okay. So force equal to pressure into area, and this will also be equal to M into G under equilibrium condition. Okay. From 1 and 2, we have. So it means gamma delta V by V, A delta P by mg. Na? We can replace PA by mg. So can I write it as A delta X by V? Change in volume, because cross sectional area will remain same. Okay. So change in volume is this much, na? The amount by which the piston is compressed. And because this distance is delta X, so change in volume will be A into delta X. Na? See, delta V is area into length. So gas is monatomic. Na? And what is gamma?
5 by 3.
Yes. Gamma is 1 plus 2 by 3, that is 5 by 3. So therefore, A delta P 5 by 3 mg, A delta X by V. Now, we know that in case of SHM, force is given by m omega square x. Na? So now in our case, this is mass, this is x. So rest of the quantity will be omega square. And the left hand side is force, na? You can see. Okay. So comparing 3 and 4, we get omega square equal to 5GA by 3V. So this gives angular frequency. We need to calculate angular frequency or frequency? Angular. So A option is the answer. Please check. If they ask about frequency, then you need to calculate S. Then you need to divide this omega by a factor of 2 pi. That will be the answer. Everyone, please check.
So M is the mass of gas, no?
M is the mass of the piston, not the gas. Piston is oscillating, na? Gas is not oscillating.
But the force is due to the gas to the piston, no?
Yes. But the piston is also exerting some weight on the gas, na? M into G. Okay.
Okay. So those forces make the SHM, no?
Make a?
Those two forces, that is the mg and the PA, those two forces make the SHM, no? Simple harmonic motion.
Yes, because of those two forces.
Yes,
it
one
is
is
oscillating.
Yes. Okay.
Actually, it is frictionless, na? So that's why when we just as you press the spring, then it keeps on oscillating for some time, na? Up, down, up, down, up, down.
Yes,
sir. So same thing is happening over here, because the piston is frictionless. So first of all, you are pressing the piston, and when you are releasing it, it will go up, and again it will keep on oscillating like this. And why it is coming down again? Because of that mg, na?
Due to its weight, yeah.
Due to its own weight. Mg. Otherwise, it will not come down, na? So it is oscillating around its equilibrium position. Okay. It is given. See, about the point of equilibrium. And at the point of equilibrium, both the forces are balanced. Na? The weight of the piston and the pressure exerted by gas, both are balanced.
Yes, sir.
Yes, sir.
So that's why I have taken this one. Clear now?
Yes, sir. Yes, sir.
So these oscillations are small actually. Only then it is SHM, just like your simple pendulum type. In simple pendulum, time period is 2 pi L by G square root only when the angle is small. Do you remember?
Yes, sir.
You know this or not?
Yes, sir.
So that's why in the question they are mentioning about small oscillation, because if the amplitude of oscillation is large, then we cannot neglect those terms that we have neglected. Clear?
Yes, sir.
So an aluminium. Now try to solve this. This one is from RD Jain. Based on principle of calorimetry, the kind of questions we discussed yesterday. Try to solve it. So volume of water is given, so you can calculate the mass of water first of all. Density of water is given. Point 0.5 kilogram. This 0.001 is because of conversion of liter to meter cube. Yes, they were very good. So now aluminium plate. Okay, so it means water will absorb the heat and aluminium plate will lose the heat. So according to principle of calorimetry, heat gained by water should be equal to heat lost by aluminium plate, and from there we can get the temperature of aluminium plate. So heat gained by water. Mass is 0.5. C is 4200. Temperature 20. So I can directly take the difference of 23 and 20, na? Because the difference will remain same whether we take it in Kelvin or. Very good, Mamta. So let us keep this as such. Heat lost by aluminium plate. 0.1 into 900, and its temperature changes from 95 to 23. 95 to 23. No, this we have to find. Let us assume it becomes theta. Okay. So according to principle of.
Sir, no requirement to convert the unit of temperature to Kelvin.
The difference will remain same, na? Because you will be adding 273 to both of them. Tanmay and Rita, it's wrong. If you add 273 to this and 273 to this, what will be the difference?
Okay, okay, sir.
Is there any change? Very good, Abhay. Good, Uzma. 70. Final temperature will be 25. Everyone, please check. Clear?
Yes, sir.
So in IIT JAM, you can note down in IIT JAM 2019, they have asked you about the definition of isothermal. Okay, let me write the question. Isothermal compressibility is given by. Simple, straightforward. Similarly, they can ask you about bulk modulus also. And they have given the options. First one is 1 by V, curly V by curly P at constant temperature, at constant volume. V. This one is from IIT JAM 2019. Very good, Arun, Siddesh, Mamta, Uzma, it's wrong. Very good, Divya, Kapil, Tanmya. It's wrong, Rita. Very good, Manjul. Very good, Abhay. Very good, Kanaya. Clearly, it's C option. Na? We have done it so many times. It is C option, not A option. A was given in one of the questions. They have given this value, but actual value, it includes this negative value. Thermally, nitrogen. Is it isothermal or adiabatic?
Adiabatic.
How come you know?
So in isolated container.
Okay, very good. So adiabatic process, and we need to calculate the change in temperature. And what is the other thing? Pressure. So you can make use of this equation. Huh?
Yes, sir.
So you need to calculate T2 and then T2 minus T1. That's how we have to proceed. This one, T1, 1 atmosphere, then it becomes 2 atmosphere. Gamma will be 7 by 5, diatomic. T1, 27.24 plus 2. Now it should be in Kelvin. So it is 1 by 2, 5 by 7 minus 1, 2 by 7. This much Kelvin. So we can write it as 2 raised to power 2 by 7. Okay. So please calculate T2. What is the value of T2? T2 is 189. It should be in Kelvin. And it will be greater, I think.
So in Kelvin, that is 171.
T2.
Yes, T2.
It's not possible according to me. It should be more than 300 because it is 2 raised to power 2 by 7.
That's 365.
3?
65.
Point, or is it exact?
0.7.
0.7. This seems to be the correct one.
So exactly how can you write T2 equals to this place, 2 to the power minus 27. That might be
2 to the power
minus 27.
minus. Why it is minus? It is plus, na? It was 1 by 2 earlier. That's why I have made it 2 now.
Okay.
So either you do 1 by 2 raised to power minus 2 by 7 or 2 raised to power 2 by 7. One and the same thing. Minus 300.24. How much? So it will be like 65.70. 46. Na? Same will be the difference in degree, centigrade, and Kelvin. Now it doesn't matter. Difference is difference. Clear? This is the answer. Please check. Done?
Yes, sir.
This one is from RT Jam. Now, very important concept I need to tell you in this question. But first of all, you can try it. Then I will tell you. Let us see how many of you are able to solve it. Okay, let me tell you, in this question, heat capacity, it depends upon temperature. And because there will be exchange of heat between the two systems. So when the temperature of the two systems changes, their heat capacity will also change. So you cannot directly calculate the heat gained or lost by using that formula MC delta T. So here integration has to be done in order to, because the CV is dependent upon temperature. So in order to calculate the total heat gained or lost, you need to integrate that MC dt. It will become integration of MC dt. Okay. That is the funda. Let me write this thing over here. Because CV is equal to beta TQ. So as the system exchanges heat and change its temperature, its heat capacity also changes with temperature. Therefore, in this type of problem, please note down.
The answer.
Everyone done?
Yes, sir.
So therefore, in this type of problem, we have to integrate MC dt to get the total heat gained or lost. Concept is clear, na? Why we need to integrate? Because C is not a constant now. Okay, and this process is continuous, na? This heat flow. Because if the system is exchanging heat, its temperature keep on changing continuously. And whenever something continuous is there, we use integration. Na? For discrete, we use summation. Clear?
Yes, sir.
Because we have to sum up. Na? That's why integration. So now you can try it. Now you know the formula. So fill in the blank time. Let me calculate the heat lost. One system was at 300, other at 400. Let the final temperature is T. Heat gained. So I'm not taking care of the sign here, okay? In both the cases, I'm integrating from initial to final temperature. So what I will do now is I will take the sum to be equal to 0 because sign is already involved like this. So now I will take heat lost plus heat gained equal to 0. Because now heat lost, it involves the negative sign also. No? Or otherwise you can integrate it from T to 300. Or heat lost from T to 400 like this. Okay, smaller to larger. Then you can write heat lost equal to heat gained. Clear? You will yourself see after solving this. No? If you just put them equal, you are not going to get the value of T because they will get cancelled. Just try to put these two quantities equal to each other. Can they be equal according to you? No, no.
Yeah.
They cannot. Because everything is same. How can this be different for the two equal equations, expressions? Okay, they cannot. So m beta by 4 can be taken as common, and we are left with. So 2t power 4. This one. So now you need to solve this smartly. Now, obviously, I can take 100 power 4 common from both of these. So when I take 1 by 4 onto this side, what is this 4 power 4? 256. 81 by 2 power 1 by 4. This is 337 by 2. Please solve this one. How much?
360.
This is the answer then. Please check this one. Clear?
Yes.
Now I want you to answer this. Yes. What is the correct option? Very good, Arun and Tamya. Very good, Abhay. Divya, it's wrong. In fact, I have already discussed with you regarding K. I think I have discussed. Very good, Siddesh. Very good, Sanju. This is the coefficient of volume expansion. It's wrong, Rita and Ritika. So I have written their formula. Now, so alpha depends upon temperature. Alpha depends upon temperature because volume and volume will get cancelled, and temperature is what? Intensive or extensive? It is intensive. And K depends upon pressure. Pressure is also intensive. So it means alpha and K both are intensive. Okay. So you can write alpha depends upon temperature as the temperature is an intensive variable. So alpha is also an intensive variable. Similarly, K depends upon pressure as pressure is an intensive variable. That's how you can solve it.
So can you show the previous slide, sir?
Yes.
So can you show the previous slide?
Yes.
Okay, sir. सर वॉल्यूम एक्सपेंशन है तो साइज में तो चेंज होगा ना
किसमें?
वॉल्यूम
Yes. What sign?
सर वॉल्यूम एक्सपेंशन होगा तो वॉल्यूम के साइज में चेंज होगा
But it is dV by V, not only V.
ओके सर
It is dependent upon dV by V, not on dV or not on V only. So Saturday we will start with Carnot engine and then refrigerator. Okay, those articles.
एक्सक्यूज मी सर
Yes.
सर द ब्लैक बॉडी रेडिएशन पार्ट इज आल्सो दैट सो वी आर नॉट गोइंग टू स्टडी दैट राइट नाउ
Black body radiation, etc. That we will discuss while discussing statistical mechanics.
ओके सर
Right now, thermodynamics is going on. After completing all the thermodynamic part. So till now we have done first law of thermodynamic and of course kinetic theory, and then principle of calorimetry type of question. So we have to do second law of thermodynamic base, that is and entropy problems. And after that we will move on towards the statistical mechanics part. Now this question is similar to the earlier question. Again, Cp, it is dependent upon temperature. Na? So again, we need to integrate it. So I'm not going to solve this question. You will solve it yourself. I will make the equation only, okay? So again, similar kind of equations will be there. Heat lost, heat gained, we need to calculate. And then again, their sum is taken to be equal to 0. Of course, it is going to be lengthy, little bit. So let the final temperature is theta, first of all. Let the final temperature of the mixture is theta. So heat lost M, 600 plus 273, theta plus 273. This, na? Because it is not linearly dependent on T, na? Because of T square, I'm solving it in Kelvin. Otherwise, I could have gone with the degree centigrade only. Okay. So this is one equation, you can solve it. And heat gained. I think that mass is different, na, in both the cases. Let me check. It was at 0.2 kilogram. Okay, so its temperature is 300. So this will become 0.1 T plus T square by 10, 573 to theta plus 273. Okay, so now you can write heat loss plus heat gain is 0, because this involves the sign also. And then you can calculate theta, which is the final temperature. And let me tell you, this theta will come out to be 792 Kelvin, which is 519. Now you can check your answer yourself later on. D option will be the answer. I think you can do it now.
Yes, sir.
So that was all for today. So we have done with first law of thermodynamics, okay, and the calorimetry type. So Saturday's topic is going to be Carnot engine, second law of thermodynamics, refrigerator, etc. Okay, so you can take a reading of that. So that's all for today, students. Okay, bye bye. Take care.
Thank you, sir.
Okay, sir.
Okay.